Good morning, everybody. So as we know already, we studied in the last class what is floating and sinking, and as well as principle of flotation. So principle of flotation, you might be noticed, always either the object will float or object will sink in a given liquid depends on two densities. Anybody can tell me what is the densities? Object, either it will sink.
Density of the object and density of water.
Yes, not water, liquid. Okay. So either any kind of object will sink or float in a given liquid is depends on what is that? Everybody? Depends on density of liquid and as well as what? Harijaras? And density of object. Is it yes or no? So that is what you have to remember. Now, we have been made so many conclusions. Just remember that if immersed portion is increases, buoyancy force increases or decreases? Immersed portion increases. Buoyancy force decreases or increases? All of you.
Increases.
Increases, sir.
Buoyancy force increases or decreases? Sorry?
Increases, sir.
Increases, because immersed portion is less, buoyancy force is less. Immersed portion is greater, buoyancy force is also greater. Next, we have taken object density is sigma. Object density is sigma, and density of fluid or liquid, fluid density is D. And yesterday we made the three conclusions. So as we all knows that upthrust, what is the upthrust formula? Mitaksri, Abhirami, upthrust is equals to what is the formula? Density of liquid into volume of the liquid displaced by the immersed or what we can say submerged part of the body into acceleration due to gravity. Is it yes or no, guys? Everyone?
Yes, sir.
Yes. Volume of the liquid displaced is V1. Next, same way weight. What is the weight formula? Weight, as we know, any kind of object, if it is submerged inside the object, it is having two forces. One force is downwards, weight. Another force is upwards, buoyancy force. So this buoyancy force only we used to call it as upthrust. Upthrust is equals to density of liquid into volume of the liquid displaced by what part? By immersed part of the body into acceleration due to gravity. What is the weight? Anybody tell me? Weight is equals to what?
Mass into acceleration.
Density of solid into volume of object. That is what a solid object or object. Density of object into volume of object into what will come? Acceleration due to gravity. Is it a sir? Everyone?
Yes, sir.
And as we know that volume of the object is equals to volume of the liquid displaced by the object. Is it yes, guys? When it is immersed. Are you clear, everybody? So finally we know that density understanding, and it will come basically equation whenever we will take object is sinking, means who is greater, density of object or density of fluid? Everyone, density of object is greater than density of fluid, then object will sink or float? Object will.
It will sink.
Next, density of object is less than density of liquid or fluid, object will float. Now, density of object is equals to density of fluid, object will float. Where it will float, Sai? Hari? Float above, and this is what, Akilan?
Below the surface.
Below surface. So that is what you all should remember. So this is how the density is related to sinking, floating, and as well as floating below or above the surface. Do you all understand, everybody? Now, after this, one more interesting thing today I will teach you. So observe one more thing carefully. So which we already studied yesterday, relative density. So relative density means what is the formula, everybody? All of you, relative density will represent RD. Relative density is equals to, yes, please.
Density of a substance divided by density of water at
Of density of a given substance, yes, Mr. Omar, divided by density of water, at what temperature, Mr. Balaji? At 4 degrees Celsius. Okay, so this is only called as relative density. So relative density has no units. No units is there for relative density. Is it okay? Harish Umar, Mitakshri, Akilan?
Yes, sir.
That is one. Now, according to relative density, also we can make. Yes. Okay, Umar. No issues. Now, relative density means, as we know that, density of a given substance divided by density of water at 4 degrees Celsius. Now, remember, according to this also I'll make, if relative density is less than 1, all of you should remember, if relative density is less than 1, then object will float or sink. Hari, Kaushik, open your mouth, Kaushik, simply don't sit. The object will sink or float. Everybody, Hari,
Float, sir.
object will float. All of you should remember. If float where? Above surface or below surface?
Above surface.
Okay, that is what you have to remember. If RD, Divya, understand Divya? RD is equals to 1. Relative density formula is very important, very simple. Density of a given substance divided by density of water at 4 degrees Celsius. That's all. Now, density is equals to, relative density is equals to 1. So object will float. Float where?
Below
Float
the surface.
Below the surface.
surface. Okay. Next, if RD relative density is greater than 1, then what will happen, guys? Object will. Okay. So this is what you all should need to remember. Now, the important concept I am going to say you. So that is what immersed portion. So let us, as we know that already, density of the fluid increases, then buoyancy force increases or decreases. That is what my question. All of you? Yes, please. Density of fluid increases, buoyancy force increases or decreases. I am asking the question. Yes, Akilan? Density increases, density of fluid, or we can say liquid. Density of liquid increases. What about to the buoyancy force? Yes, everybody?
That also increases.
Then buoyant force or upthrust also increases. Yes, Harish? Yes. Now, observe very carefully. Now I will put one statement and I will try to prove. The statement is, all of you should write. Actually, you write it, everyone. Very important. Right. If the density of the fluid increases, write the statement first. If the density of the fluid increases, then the immersed portion of the body decreases. The density of the fluid is increases, then the immersed portion of the body decreases. Have you understand? How many of you understand this statement? Yes, all of you. Please. Now, Let us take everybody. I am taking it to different containers. Observe very carefully. Now, let me take 3 different containers. Is it okay, Hari? All of you, Kaushik? Now,
Yes, sir.
you will notice it. Let me take in the first container, I have been filled with normal water. What have been filled? Normal water. Second one, if I have taken, I have been filled with something. Let me take now salt water. Second one is filled with what? Salt water. And the third one is filled with glycerin. Filled with what, Hari?
Glycerin.
Glycerin. So neatly noted down. So what is that meaning? You will understand now. So this is, what is that, guys? Normal water. Are you understand, everybody? Normal water. Okay. Now, what is this one, everyone? All of you. Salt water. Okay. Next. This one is glycerin. Are you understanding, everybody? So now, observe, all of you, write the densities of normal water. What is the density of normal water?
1 gram per cubic centimeter, sir.
Cubic centimeter. Yes, very good. So now, all of you, glycerin or glycerol, you can take. So glycerin density, if you have taken, all of you, 1 point glycerol, you can take glycerol. So glycerol or glycerin, let it be. So the density is 1.25 gram per cubic centimeter. Is it okay? Now, density of salt water. First, density of water you write. Density of water is 1 gram per cubic meter. Density of water is how much? 1 gram per cubic meter. Now, salt water, if you have taken, salt water density is 1.020. Okay? Or 1.029 basically it will come. So it will be varies. So gram per cubic centimeter. All of you write it. Densities. Have you understand, Harizaras? So densities, how it will varies? Gram per cubic centimeter. So this is what? Water density, salt water, and I have taken another one is glycerol. So now if you'll observe, all of you, I have taken one object. That object is some, let me take that object also. Now all the cases object is floating. Understand, Mitakshri? All the cases object is what? Floating. Okay. Now observe very carefully. Here the immersed portion is more. Here little bit less, and here more or less. So that is what you all should understand. So here immersed portion is half, and here immersed very little is floating. Now tell me what is the difference you are seeing? Anybody? So if you notice it, in this case, till here the object is immersed. Only less portion is above the surface. Here almost half of the object is inside, only above is very less. And here very small thing is immersed, remaining all it is above surface. So what you are finding? Everywhere is same object. What is the difference you are finding? See, everywhere floating only, but here immersed portion is more and floating, the appearing above the surface is less. Okay, now here immersed portion is exactly half, and here immersed portion is just, it is like very small. So let me take the density of the object is, when it will float, guys, it must be less than or more than, all of you, less than or more than liquid density, all of you, less than. So let me take density of object is 0.5 gram per cubic centimeter. What is that? All of you, hurry. 0.5 gram per cubic centimeter. Now, here is the logic. What is the density of this object? Also same, because same object I am saying. 0.5 gram per cubic centimeter. Here also 0.5 gram per cubic centimeter. Now, But here see, most of the object is immersed. Yes or no? Yes, Akilan? Divya? Understand or not? Most of the object is immersed. Here, half of the object is immersed. And here, very less percentage of object is immersed. Now, sir, why it is happening? Let us see. Can you find the difference between these two densities? Difference between this object density and liquid density? All of you, hurry. Difference in densities. I want it. Difference in densities. Case 1. All of you tell me. Yes, please. Density of liquid minus floating it is. Density of object which is equals to 1 minus 0.5. Understand which is equals to how much, guys? 0.5 gram per cubic centimeter. Is it right or wrong? Everybody? Mr. Johan? Unless you will speak, you cannot. Next, case 2. Can you tell me case 2 what is happening? D minus density of liquid minus density of object is, what is the density of liquid? 1.029 minus 0.5. What is the difference, Hari? Everybody should solve. Don't know that also, I cannot do anything. You have to solve and tell me. How much it will come? 0.529 gram per cubic centimeter. Is it more or less difference? Difference is more or less. Now, case 3. Abhiram, understanding? Density,
Yes, sir.
density of liquid minus density of object is how much, Omar? See that glycerol density, how much it is? 1.25. Understanding? Glycerol. Or else you can take glycerin also, no issues. 1.25 it will come. So glycerin. So GLYCERIN, glycerin or glycerol, whatever it is. Now what are the densities, guys? 1.25 minus 0.5. How much is the answer?
0.75.
Very good. 1.25 minus 0.5 is 0.75 gram per cubic centimeter. Is it yes or no, Ashwin Balaji? Everybody try to answer. Now, if you notice it, where the density difference is more, guys, observe. Density difference is more where?
In case 3, sir.
In case 3. So that is what it is. So now you tell me, in the given 3 liquids, who will exert greater buoyancy force? More buoyancy force? Anyone? Akilan?
Case
Yes, sir.
3.
Very good. See, intelligent questions, we have to think and we have to answer. So now 3 different substances, same object is sinking, but all the cases it is floating only, but immersed portion is more. Immersed portion is more, here little less, and here it is little more less. Now where the buoyancy force is greater? Anybody can tell?
Glycerin.
Here is the buoyancy force is greater. Understanding? Here a buoyancy force is next. And where is the buoyancy force is least? Here. Understanding? So buoyancy force is least here, medium, and here what? Maximum. Understand, Hari? More or maximum. Okay? Because density of the liquid is here more. So all of you should understand that density difference between object and liquid is increases, then immersed portion will decreases or increases, guys. Immersed portion will decreases, but buoyancy force will increases. Understand, all of you? Mitakshri, Harish, Eras, that is what I said. So a density of fluid increases, then a buoyancy force also increases. So same object, more immersed in the liquid, less immersed, and here least immersed in the liquid. That is what you have to remember it. So that is why now I want to say one question here. So now you tell me, In which one it is easy to swim? Normal water or ocean water? Anybody can think based upon this concept?
Ocean water, sir.
All of you. In which water you can swim easily? Normal river water
Ocean
or
water, sir.
ocean water? Everybody? Sorry, Omar, chart at least. Johan, at least chart you can say, Johan. Yes or no, like that. Yes, please, guys. Who will say? Abhinami, Mitakshri, Divya,
Sir, ocean water.
ocean water. Why ocean water? It is easy to swim. Anyone?
Sir, more salt content.
More salt content. So density difference is more. So that is why it is observed. It is easier to swim in seawater or ocean water, seawater than river water. Okay, people will think, sir, river means water is flowing so that we can swim fastly. I am not asking flowing or not. Basically, if I'll give seawater and river water, so if I'll take one beaker seawater, and if I'll take another beaker river water, okay, so definitely our body is having some density. Yes or no, guys? Suppose now Homer is swimming in both the cases. Now here the density between seawater and Homer is more or less. Yes or no? Density difference.
Yes.
Density difference is more. How less it is? Because seawater is having what? Seawater is having more density. Understand, everybody? And this one is also. And here river water, if you have taken, river water density is 1 gram per cubic centimeter. For example, now Homer density is 0.5 meter per, gram per cubic centimeter. And seawater density is 1 point almost 0.029. So density difference is how much, Hari? 0.529 gram per cubic centimeter. But here Homer density is 0.5. So this is 1. So 1 minus 0.5, which is equals to 0.5 gram per cubic centimeter. So where the density difference is more? Seawater or river water?
Seawater, sir.
Seawater.
Seawater. So that where buoyancy force is more? Seawater or river water?
Seawater, sir.
Seawater.
Seawater. That is why. So the body will be feel more lighter or more heavy. Our body. Yes, please.
Lighter, sir.
Lighter. Understanding? So when we are swimming in seawater, our body will experience greater buoyancy force because the immersed portion is less or more. Anybody? Immersed portion is less or more. Immersed portion less compared to river water. Do you understand, everybody? Mitakshri, Akilan, Gokul?
Yes, sir.
So in seawater, our immersed portion is less because of greater density difference. So more buoyancy force is exerting on us so that we can swim easily. Is it okay, everybody? Yes?
Yes, sir.
sir.
So that is what all of you should remember. Now, let us take one numerical we'll solve. Let us solve that numerical. Later we'll go for applications of flotation. So please write numerical. A piece of material of mass, numerical, write, everybody. Example 1. You can take our numerical 1. Write the question, all of you. A piece of material of mass, a piece of material of mass, 100 gram is 100 gram is immersed in a measuring cylinder. Immersed in a measuring cylinder. Can you able to write it, everybody? Divya? Right. A piece of material of mass 100 gram is immersed in a measuring cylinder. Immersed in a measuring cylinder. Immersed in a measuring cylinder having water having water at a mark of 30 ml. At a mark of how much? At a mark of
30 ml.
30 ml. This question is very important. How smart it is, you see that. None of you can have answer it except 2 or 3 persons. So having a measuring beaker. So what is the water level initially? Everybody. Yes, please. What is the water level, Hari?
30 ml, sir.
30 ml. Understanding? This is what it is, 30 ml mark. Let me take, this is a 30 ml mark. I'm trying to draw the diagram. 30 ml. Okay, full stop. Full stop. Calculate Roman number 1. Roman number 1. Volume of the piece of the material. Volume of the piece of the material. Oh, sorry, I am not in the question. So till where you are written? Can you tell me the question?
Mark of 30 ml, sir.
Water 30 ml, full stop. Right, next point. The water level rises to 38 ml. The water level rises to 38 ml. The water level rises to 38 ml. Means if I'll drip 100 ml, 100 grams of object, so that it is acting how much, guys? Anybody? So if I'll drop now 100 grams of weight, so that water level is rising to where? Water level is rising to where? All of you?
38 ml, sir.
Yes, please.
38 ml.
38 ml. So means what is the change in volume? Anybody?
8 ml.
Volume. Change in volume is how much? Water level increases. Before it is 30. Now the water level is increases how much?
38 ml.
38 ml. So that is what you have to remember. That is what they are saying the question. 38 ml. So first, Roman number 1. Solve one by one. What is the volume of the piece of material? Volume of the piece of material. Shall we start now? Volume of the piece of the material. Everybody? So as we know that they have given liquid. What is the given liquid they have given? Check it, everybody. What
Water,
is
sir.
liquid? Water. Understand, everyone? So this is 100 grams water. Now, what is the mass of the given material? All of you, first mass you write. Mass is equals to how much? 100 grams.
100 grams.
Now, what is the initial volume of the water? All of you, initial volume.
30
Initial
ml.
volume of the water. Let me take V1. V1 is how much, guys? 30 ml. Okay. What is the final final volume after immersing? Final volume
38.
38 ml. So what is the volume displaced, guys? What is the volume displaced?
8
8
ml.
ml.
Yes, volume of displaced liquid. Displaced liquid is equals to V2 minus V1. So V is equals to 38 minus 30, which is equals to how many ml, guys? Sorry, how many ml, Omar? 8
8
ml.
ml.
Harizeras, understand, Gokul? 8 ml.
Yes,
Now,
sir.
you might be remember, let me take the volume of the object is V1 and volume of the liquid displaced is V. Both are equal or not? Yes or no? Yes, everybody? All of you should know. We know volume of the liquid displaced is equals to volume of the object. Volume of the object. So now, so I can say volume of the object is equals to what, Hari? 8 ml. Is it S?
Yes, sir.
But is it solid mass, solid volume will measure in milliliters? Is it solids will measure in milliliters? That is what my question asking. Anybody can tell? All of you?
No, sir.
Let me take, this is VORA, object volume. Is it possible to measure the volume of a solids in milliliters? That is what my question. Anyone? No.
Cubic centimeter.
Okay, so you must write in either cubic centimeter or cubic meter. So solids volume we were never supposed to measure in milliliters. So that is why we must write here. We know water they have given. So 1 ml of water is equals to how many cubic centimeters, guys?
1 cubic centimeter.
1 cubic centimeter. So volume of the object is equals to 8 into 1 cubic centimeter, which is equals to how much, guys? 8 cubic
Eight.
centimeter. That is what volume of the solid. Is it okay, everybody? Divya, understand this question? Harini? That is what. So remember always the volume of the liquid displaced is equals to volume of the object. That's all it is. So 8 cubic centimeter. Roman number 1. Anything? Anybody having doubt? Please. Now, Roman number 2. Write it. Roman number 2. Density of the piece of the material. Density of the piece of the material. Calculate density of the piece of the material. So what is the formula of density? Everybody never open Arun Kailash and all. I don't know what is the use of their life. Simply sitting. What is the density formula, guys? Density is
Mass by volume.
mass by volume. So
Mass by volume.
what is the mass of the given solid? 100 grams.
100.
We got 8 cubic centimeter. Solve this one and tell me how much it will come. 2 50s are, 2 4s are, 2 2s are, 2 25s are. So 25 by 2, how much it is?
12.5, sir.
12.5 gram per cubic centimeter density. Any doubt? Anybody can ask. Are you clear? Yes?
Yes, sir.
Next. Roman number 3, loss in weight of the piece of material. So as we know that if the object is immersed in a liquid, weight will loss or not? Yes or no?
Yes, sir.
Yes.
sir.
So that is how much it is, we have to find it now. So right, loss in weight of the piece of material. So now loss in weight is equals to something. Can you tell me what is that, Mitakshree? Hari? Hari sir, loss in weight is equals to something. Can you,
Thrust.
Akilan? That is
Real
what?
weight minus apparent.
Yes. Akilan is saying buoyancy, buoyant force. Buoyant force on the, that is what fourth question. Both are equal or not? Hari?
Yes, sir.
Okay, so that is what you have to remember. So loss in weight is equals to, answers we can solve. Loss in weight is equals to Archimedes principle. Loss in weight is equals to what? Buoyant force. Do you remember or not? Buoyant force. That is only we used to call it as upthrust. So what is the formula? Anybody can tell? Buoyancy force formula. Today also I taught you. Yes,
Sir,
please.
density.
Density into volume.
Density of liquid into volume of liquid displaced into volume of liquid displaced into what is that? Acceleration due to gravity. Is it yes or no? Yes. Now, so
Yes,
what is
sir.
the density of the liquid? We know that what is the density of the liquid? Water. What is the density of the liquid? All of you.
1 gram per cubic centimeter.
1 gram per cubic centimeter into what is the volume? Volume displaced. Check it. Volume displaced how much? Volume displaced how much, Amma?
8 cubic centimeters, sir.
8 cubic centimeter into G value.
9.8.
9.8.
9.8 you should not write. 9.8 because it is in centimeters and it is SI unit. So 9.8 meter per second square. It is a SI unit. But here we are all writing in what units? Everybody. Are you asking?
Yes.
Yes. So which is equals to, remember, 980 centimeter per second square. Understand, Hari?
Yes, sir.
Mr. Kau